All right, so at this point, we've pretty much got our geometry set up here, mapped onto the individual surface. So the reason that we did this, the reason that I flattened out these panels is really kind of twofold. A, it's more realistic, right? You can get curved glass, but odds are, if you're developing a facade system for a building, they're going to do it out of flattened panels like this, right? Some kind of grid system. And also because now, if I look at it in top view, all of the geometry that I just generated is exactly in plane with the surface itself. So if I want to do a perforation, it's as simple as taking the polygon itself, making it a solid. So let's go ahead and make those surfaces. So we'll take the polygon, we'll plug it into surface, and subtracting it from the list of ruled surfaces as well. Move that down a little so we can give ourselves some room. So let's go ahead and recreate this setup right here. So we're going to do a surface difference, but we're probably not going to need it to be flattened this time because we have a list of grafted polygons that are now made solid, and we have a list of grafted surfaces, right? So they're all individual surfaces in their own little mini list. So I'm going to do a solid difference under intersect and shape. I'm going to do solid difference. So I'll just plug this in here, and I'll take the ruled surface and plug that in there. So we should be able to just turn all of this off. And oh, look at that. I love when it does stuff like this. Now, why is it doing that?
Yeah, mine's scattered as well.
All right, none of them are flipped. Okay. All right, hang on a sec. I'm going to investigate. Okay, so this has happened to me a couple times in the past where the subtractions aren't exactly punching through. So what's kind of happening is they're not exactly aligned, and this is another instance where I haven't yet found exactly why. But here's my workaround, right? And it works in all instances, pretty much. So what I actually wind up doing is, instead of worrying about a curve, right? Instead of worrying about a curve being exactly coincident with the surface that I'm trying to map it onto in these compound operations, instead what I try to do is move it off of the surface itself and then extrude it through that surface so that there is no doubt that the profile of that extrusion is actually penetrating through that surface. So it'll give us a definitive way of cutting it. And it's also, for the most part, absolutely necessary to do this when you have an actual thickened panel, which is kind of the next level of operations, which comes later down the road. But anyway, so it's done like this. Basically, what I'm going to do is take the polygon, move it off using the normal direction, and then extrude it back double the distance that I moved it off. Okay, yeah, so you'll see what I mean once I actually go through it. So let me disconnect this, and we're going to work with this surface. So I'll just put that up there for now. Preview those. I'm going to put the original surface back on, and let's kind of watch it. Let's watch it up here in the corner. Watch what's happening. So under display, I want you to be aware that there's this thing called vector display. It shows you the direction that a vector is going to go. And so I can turn on vector display here, which allows me to plug in this surface normal that I got from the evaluate surface. I can plug it into vector, and I can take the anchor point as well, and it's going to show me the direction that the surface is facing, right? So that's the surface normal positive direction. That's the z-axis positive direction orientation of that surface. So I can delete that. I just threw that on there to show you. So anyway, I am going to move this surface off of the panel. So I'm going to go to transform, Euclidean, and I'm going to move. And move is going to require the geometry that you're trying to move. And it's going to require a translation vector. And a vector has what two components? Magnitude and what? Direction. Direction and magnitude. Magnitude and direction. A vector must have that. So what we're going to do is obviously we're going to move the geometry. And you'll see that it kind of makes a copy of it up there. Remember that when I say move, it really just means I have to make a copy, right? Because it doesn't delete old geometry. So it makes a copy of it up there, and that's because it's preloaded with a distance in the z direction of 10. And so what I'm going to do is reorient that so that it moves it in the direction of the normal instead. However, when I take this normal is just a direction. It doesn't have magnitude. So when I plug it in, well, I guess it has a very small magnitude, actually. So the preloaded magnitude, I think, is a value of 1 rather than 10. But I want to be sure that I can control exactly how far it's going. And so this is, I think, the first time we're using amplify to change the magnitude of a vector. So I'm going to go under vector, and I'm going to use this component called amplitude. Now this is going to request that you give it the base vector direction, and then it's going to ask for the amplitude or length value. It's a numerical value. So the normal gets plugged into V, and we'll add a slider to A, so 0, 5.5 to 10. Doesn't really matter what it is. And then I'm going to plug this vector that has direction and magnitude into the T translation vector of the motion. So you can see now it kind of sits off a little bit from the surface. The actual exact number doesn't really matter because I'm going to create a mathematical relationship where it now extrudes it back the other direction, double that amount. So no matter where these panels are, they're absolutely going to be cut by this polygon. You guys need a moment to get caught up before I move on? I see no shaking heads, so I'm going to keep going. So that was move. That's step one. Take it off of the surface. The next one is to extrude it back the other direction. So working backwards from the extrude command, I'm going to go to surface and freeform. And I'm going to extrude. And it, very similar to move, is just going to ask for the base geometry, right? And it's going to ask for the extrusion direction and magnitude, right? So that is pretty much the same thing. So the geometry is going to be what we just moved. That's this right here. We're just going to double up and put that geometry back in. And the direction is going to be the normal, again, but we're going to reverse its direction. So we can take, we'll take this normal and we'll go under vector, and we're going to use reverse. I'll plug that in. So that changes its direction. Move that out of the way. Put this up here. It's getting a little crazy here. I'll clean this up in a moment. But so that changes its direction, but I also still have to change its magnitude. And I mentioned that its magnitude is going to be twice the distance of the amplitude where I moved it off of the surface in the first place. Yeah, so it goes all the way through. Inevitably, it will always go through the surface. So that's really another amplitude function. So I'm going to go to vector, vector, and drop in another amplitude. But this one is going to use a mathematical operator, and it's going to be tied to the same amplitude that I just defined. So I'll go to math, operators, and I'll do multiplication. And a static number of 2. So I'm going to say this slider times 2 is my amplitude. And the reverse direction of the vector, of the normal, is where I want it to go. So now when I plug this into Extrude, you'll see that it goes exactly that distance on both sides. Looks pretty crazy, huh? Any questions so far? All right, so I'm going to do this just in the same video because all we have to do is trim it out in order to finish this up. I don't want to do a separate video for that. Solid difference might work, but sometimes it doesn't work when there's a flat plane and a volumetric solid, but we can try it. So I'm going to take this solid difference and just plug the extrusion into it and see how it does. And what it did was basically it added them together. Okay, so we've got all of these extrusions, we have all of those surfaces, and it didn't work. So rather than solid difference, we have some other options. Under intersect and shape, we can use trim solid. So trim solid is going to ask for a shape to trim, and then it'll ask for trimming shapes, which basically means which shapes am I going to use to cut with. And so if we plug the extrusions in as our trimming shapes, and if we plug the ruled surface in as our shape to trim, let me turn that off. Turn all these off as well, and this. You'll see that we've successfully cut through the panels. So kind of a lot happened here. Let me drop a slider on here to kind of animate it a little bit. There we go. It seems like kind of a lot happened here, but it's really just two main moves. We took the polygon. Let me kind of highlight them for you. I'll make this. Oh, come on. What? What is going on? So we took the polygon, and then we. Wow, this screen is too small. Then we moved it out, and then we extruded it back. That's really, all of this just relates to that. Those three things. And all of this stuff is just vector support right here. All of it. It's all just vector-based modification, reorientation, amplification, all of that. Questions? Yes? Okay. I will come around and troubleshoot with all of you individually. I'm going to stop this video.